Welcome to the lesson 1.1, my first ever lesson that is online. As I've suggested to you, you should write the title as well as the I can statement on the top of your page. It makes it a whole lot easier when you're reviewing for the test whether or not you can do what we expected you to be able to do in each one of the lesson. So the title for the first lesson is Recursively Defined Sequences, and the I can statement is for you to identify and write recursive formula for arithmetic and geometric sequences. As always, you can pause to take the time to write these down. You can forward, you can move to the next slide. It is for your benefit, it is for your pacing. A few definitions that you need to know, and the first one is the word recursion. The definition of recursion is a process in which each step of the pattern is dependent on the step of steps that come before it. So for example, 2, 4, 6, 8, you will know that the next one will be 10 because of all the steps, all the numbers that I have given you beforehand. So the first definition you need to know is the word recursion. Here's the first example. Suppose you have a square table that can seat 4 people. If you have 2 square tables pushed together, you can sit 6 people. And if you have 3 tables pushed together, you can seat 8 people. So if I was to organize this information into a table, this is what the table will look like. And I realize that the word tables got cut a little bit. But as you can see, 1 table will sit 4, 2 will sit 6, 3 will be 8, 4 will be 10, and so forth. 5 will be 12, 6 will be 14, 7 will be 16. I can take the same information that is being organized in a table and actually put it into a graph. So here's what the graph will look like. So if I have 1 table, I'm not really drawing this to scale just because of the square and the limitation here that I have. But if I have 1 table, I can sit 4 people. If I have 2 tables, I can comfortably sit 6 people. If I have 3 tables, I can sit 8 people. And you probably notice the pattern. So my next question for you to think about is, as you've learned in your previous math courses, that sometimes you need to connect the dots. In this particular case, we are not going to connect the dots. The reason is because we can't have 1.5 tables. Neither can we have 2.5 people. So therefore, this type of graph is called discrete. And we will explore more about these type of graph in a later lesson. But for now, do know that we should not connect the dots at this point. So as you can see, the same information can be organized in either a table or in a graphical manner. So here's a couple of things, more definition that you need to know. The next word is the word sequence. And sequence is an ordered list of numbers. So our example was 4, 6, 8, 10, and so forth. Of course, the next one will be 12 and 14. Do know that each number in this sequence is called a term. So number 4 would be our first term, 6 would be our second term, 8 would be our third term, and so forth. All right, so 2 words that you need to know, sequence and term. So here's the important part, okay? And this is the main part of the lesson, and that is for every single sequence, we need to be able to write a recursive formula. And recursive formula is a formula that defines a sequence, okay? Two things that it has to have. It has to have a starting term. You need to tell me what number I'm going to start with. And you need to have a rule that will tell me the next term or the nth term in relation to the previous term. So for example, our starting terms was 4 people sitting at one table. Then the recursive rule was that for each additional table, we can sit an additional 2 people. So instead of writing the word starting term every single time, mathematically we write it as U1. And that represents the first term of the sequence. Again, it's read U sub 1, and that's the first term. So we will write this as U1 equals 4. That will be the starting term. For the recursive rule, instead of writing the word recursive rule every single time, we write it as UN is equal to UN minus 1 plus, in our case it would be a plus 2, or in some cases it will be a minus. So that is the rule to generate the next term. So for our purpose, we're going to write U1 plus 2. And n is the number of terms, okay? When n is equal to 2, that means that we're looking for the second terms. When n is equal to 3, that means that we're looking for the third terms, okay? So what this will look like is, for example, U1, that's when n is equal to 1. That's the first term in the sequence. That will equal to 4. For n equals to 2, meaning that we're looking for the second term in the sequence, it is written this way. U sub 2. Again, this 2 represents the second term. In order for you to find the second term in the sequence, you must take the previous term, which is indicated by U2 minus 1. Again, 2 minus 1 is equivalent to 1. And we're going to add 2 to it. Okay? So this is what it looks like now. It would be U1, meaning take your first term and add 2. So I'm going to take my first term, which is 4, and I'm going to add 2. Which means when we're looking for U sub 2, the second term, it will then equals to 6. The same thing can happen if you're looking for, let's say, the third term. So let me erase this out. Let's say you're looking for the third term. So all of this n will now be 3. So let me remind you again that we were solving for U sub 2 earlier, and we got U sub 2 is equal to 6. All right. So now suppose we're looking for the third term. So now n is going to equal to 3. Well, U sub 3, okay, again, looking for the third term, will be the same thing as taking U sub 3 minus 1, and 3 minus 1 would be U sub 2. And U sub 2 is equal to 6. So now we're going to take the previous term, which is U2, U sub 2, which equals to 6, and we're going to add 2. So U sub 3 will now equals to 8. This U sub 1 and this UN equals to UN minus 1, is simply saying it is the notation for recursive formula. It is the most commonly used notation, and it is one that your calculators will be using. So the TI 83 and the 84 will use the letter U. And we will use your calculator. We're going to learn how to enter all this in your calculator. Now, you'll notice something. N can never, ever be negative because the first term, in this particular case, is 1. So in this particular case, we will always we have to use n is greater than 2. Because we already defined u sub 1. We already said we have n1. So the next term will be n2, n3, n4, n5, and so forth. Again, we don't have any negative integers for our term number. We can't have a negative term. Okay? So I want to remind you again, the u sub 1 equals versus the un equals to un minus 1 plus or minus something is a mere notation for recursive formula. All right, so let's move to the next slide and let's see if we can do this part.